Hello everybody. Hope you guys are doing well. Let me check. Let me check if the stream is up and running. Just give me a minute. Okay, so the stream is up and running, and yeah. So basically, now we'll be starting with text view, right? So text view is basically something that will be. It's the most commonly used view, right? I mean, we'll be using this view a lot, a number of times. So this is the most commonly used view, right? So it's very important that we understand how the view works. Okay, now remember this is a pull-in view. That means the size of the view is basically size of content, right? So size of content. Okay. Now there is something called as so now there are additional modifiers that we can use on the text, right? Uh, yeah. So first modifier that we will be referring is basically something called as line limit. So basically this is going to now the text to shows only read only text that can be modified in ways it wraps automatically. So what is going to happen is so if the text is bigger than the view, right? So like if I have multiple lines, so suppose these are multiple lines in my view, right? So now what is here, I am limiting the text to only just one line. Oh, so so if I have multiple lines, what is going to happen is this is that automatic wrap up to the next line, right? So this is not a very good way of designing, right? Like what if we want only the text to be in one straight line? Like what if we don't want the wrap up to so what we are going to do is we can do something called as a line limit, right? So if we do a line limit here and we say if we limit it only to one, so the remaining text you will get all dots, right? Nothing you won't be able to, like it won't, so the automatic wrap up to the next line will not work. Then you, so this is basically a modifier, right? Line limit modifier. Basically here you can mention how many lines you want to limit. Now then is basically something called as text styles, right? Now the text styles is basically you can you can add a text style to the text view. Okay, yeah. So what if you want to change the font, right? So like what if you want to add some additional styling to the font? The way you can do this, you can add in a modifier called as uh, so whenever you add the dot font, basically so for example, if you need to modify the text, right? For example, you need this to be large or small. So title is basically something uh, referring to what do you say? Uh, title is like H1. Then you have title 2, basically like H2. Then you have something called as title 3, which is like H3. So this is basically how the demarcation is happening, right? A caption. So now at times we will be using, For example, when you do, you need to mention a dot, or just give me a minute. Okay, so now this is basically yeah. So now quite often we have used this dot notification. As for example, if it's dot font, this is the this dot is basically indicating for, so you can change modifiers, right? So you can change modifiers to the view, and then inside what we like, at times you are going to access your, for example, dot large title, right? So what is this is so basically what we, this dot indicates that we are accessing a property from font. So basically we are basically accessing, basically that so when we write dot, it automatically reads that um because the way that font is defined is yeah, so it kind of no, let's, so yeah, basically it's a property from font type. Basically we are okay, it's a struct, I guess. Yeah, yeah, I get. So I guess it's okay. Yeah, so the thing is, these are all static properties, right? So you don't need the initialization here. Okay, let's say this. Uh, yeah, so this is like a getter and setter kind of thing, right? So internally it is represented like, so internally it is present this way, right? So remember, so this is that large title, right? and these are all static, so you don't need any, and this is a struct, so you don't need any like we don't need to create that initialization part. And this is a computed static property, right? So whenever there is a computed property, uh, so first is because it's a static, so it does not need that instance thing. But then, no, no. So let's see how to access that. Also, this font modifier is, oh yeah. So what we are passing, we're going to pass this. Remember, the return type is also like font. So we are going to pass this into my struct, right? So if I pass this into my struct, it will be font dot something, right? Okay, so the font modifier expects font property, right? And then that is going to be accessed from the font struct. So ideally, it should be font dot large title. Basically, this indicates that we are from accessing this from the font struct, and this is that property, right? So it's a static property, so no instance creation is needed. This is some okay. This font and this has nothing to do with each other. These are two different things. Then the next thing that we can do is basically you can add in weights, like whenever you can weights. Weights is basically like thickness. So like how thick the font should be. Again, you can add in. So now this is a very so there are, yeah. So font weight is only applicable to text views. Unlike font modifier can be applied to any view. To apply weight to any view using font. Yeah. So font weight. So this is basically specifically for fonts only. Oh, okay. Now weight and so weight is that thickness and then you font weight. Okay. Now font design, for example, now what is this? Okay, so you can add in. Now this is again, but then it. So there is like now you can. There is something called as font dot system. Let me check. This is font. So font dot system is a static method. That lets you create customized system. So suppose if you want to have our customized style, the font design. Oh, uh, let's instead of two modifiers, you can combine. Let's so instead of having a font title and doing a font, uh, now what is this design? Now instead of two modifiers, you can combine text style and weight in just one modifier. So you can have like font dot uh, so font dot title dot weight. Okay. Oh, so what we can do is we can add in something called as a system name, right? So what we can do is you can add dot and then so this is again font dot system and then it needs okay, so this is needing an initializer to be passed. You need to initialize this. This is not a static thing. There is some initialization that is going to happen. The font width, okay, you can set in the width as well. So there is a width. Okay, yeah. Instead of yeah, what you made by combining. So you have font dot large. So these are all static. Then you have font dot weight, right? So instead of writing this font time things many time, you can just combine them one as say font dot, or you can change them like large title dot. So the application of order is like how it's written, right? So okay, now formatting. Now this is you can either make it bold. So again, this is common, right? This is not the moment you come to formatting. You have first is bold, then you can do italics. You can do a lot of things, right? Strike through is also one. So basically, that text will be have a line on that. Mm. There is arrow tightening can be useful. Hmm. There is something called as arrow tightening, right? Now, arrow tightening can be helpful when you see last word getting truncated. Applying it may not even fully work depending upon how much you can. Mm, what's doing? What is it? So you might want to tighten up some text. Allows tightening. It's not arrow. It's allows tightening. What does they do though? What does it do? Like Oh, it's not arrow tightening. It's allow. It's allow tightening. Now, so if needed, you are allowed to slightly reduce the character spacing to make the text. Yeah, so what it is going to do is, suppose if you are having multiple text and spacing, right? So you're having multiple lines here, right? And what is going to happen is, suppose what if the text is flowing down, but you don't want that flow to happen, so you want everything to be the spaces should be adjusted so that it's on all on the same line. So you kind of do something called as allow tightening. So it will reduce in the space, I guess. Now there is something called as minimum scale factor takes a, what is this? Now you can check text to a minimum percentage of its original font. Okay, this is like, it's like what if you, okay, this is, so we are all dealing with modifiers, right? So remember, this is another one. This is minimum scale. So this is going to reduce shrink with respect to its original size. So now line spacing. Oh, this is something. So line spacing, you can use line spacing to add more spaces between. So this is, suppose these are my like I have multiple lines of text. Yeah. So this is line one and line two and line three. So line, this is line spacing between the lines. Oh, now alignment. Now this is something where we need to remember trailing. So now it makes more sense when you are dealing with text, right? To have trailing and leading edges. So alignment. So again, this is all modifiers, right? Nothing special. So either you can align it like uh, this is my leading edge, right? This is my leading. This is my trailing. This is top and this is bottom, right? So while using text, it makes sense to use that leading and trailing. Now, trunk. So how much do we want? We can change that as well. Like when we want everything to show up on a sing. Oh. So in truncation mode, now what are we going to control here? Line limit. Now truncation mode is mm, how what? That is line limit is, oh yeah. So basically, now this is used with line limit, right? Okay, so for example, this is my text, right? So by default, this is the text, and then what if I have multiple lines, right? So if I have multiple lines, then by nature is and I apply a line limit. So what this will do is it will try to fit all these lines in one line. and at the ends we'll have three dots if there is more text, right? So now what this truncation is going to do is truncation mode is going to enable us. um, so by default it's going to be that three dots are going to come at the end. So using truncation mode we can change that, and then we can select like in. So suppose if this is the line, right? So where should those three dots come? Should it come in the middle? Should it be at the start? So for example, I want the three dots to come here itself. Oh, pencil is not charged. You can control that as well. So using that we can control that truncation, right? So you can add these three dots at the start as well. So now when you do this, the three dots are at the start instead of the end. Then you can add in using plus, using combine. Although you see, oh now this is something baseline, first baseline, last baseline, and offset. Okay, so for example, we have a text, right? Say now whenever you have a text, baseline is this line. That is, yeah, this is on the same baseline, right? Now what if so like they are touching on the same. What if I want this thing to be up? Like what if I want the baseline of Swift to come up or decrease? So we can, yeah, so can you see, yeah, this is the offset that has come in. Now so if you see this is, now what is so right now so yeah, consider this as the X thing, right? So if you go below, you need to give a negative baseline. If you go above, you give it a positive baseline value. Now layout priority controls which view will get truncated last. The higher the priority. Hmm. This is some modifier. Oh, I guess what is it? So if there is no line limit applied, and what we have done is, I see what's happening here. Is it inside some? Okay, so layout priority. So what layout priority does is basically, um, yeah, I have three views, right? And all of the views so okay, so I have three text views and these are multi-line text. This is view 1. Okay, so I have three text views here. This is, so if this is text view 1, text view 2, and this is, and all of these views are going to be multi-line, right? So what layout priority does is, so it will try, we need to like, we need to have on the same screen, right? So there will be some sort of truncation that is going to happen. So what we can do is, so layout priority decides which should be truncated last, so that all are on the same screen. Now you can add in custom fonts as well. So to add custom fonts, the modifier is dot custom. Like this is, I guess, all present in the font struct, and then you can mention what you need to add in here. Oh, now this is something. For example, what we are going to, um, this is linking an external font. For example, generally, uh, something. Sometimes you are going to link fonts, right? Oh yeah, I guess it's more. Okay, so yeah, let's end this thing here, and then we will continue with more. Like we'll start with important fonts. Now this is where, you need to add custom fonts. So depending on the project, right? So this is going to be a little bit. This needs to be take. We would be doing this a lot. Uh, okay, so yeah, that's all for this session. I hope you guys liked it. I will see you guys in the next one. Till that time, take care. Bye bye. Please subscribe to the channel. Bye. Hello everybody. Hope you guys are doing well. So continuing on a journey. Uh, Today we will try to understand a little bit more. Uh, So like we did some views, right? So like we did a UI, so we'll just say a little bit more about views, the views that we use there, so that you know we can better utilize them. The next thing that we are going to do is something called as foreground color, right? Now this has been deprecated though. The newest version of this is foreground style. Now views can contain different layers that you can add a layer behind a view with the background modifier. You can add a layer in front of a view with the overlay, or you can add you or the view can already have multiple layers. The foreground color elements the affect the elements of a view that are in the front. So basically, he's trying to say. Suppose if this is a view, right? So whatever elements are in the front. So if this is in the front, the foreground color will affect the elements in front. So elements in front are going to be affected by this. Now, uh, so foreground color has been deprecated. Instead, we have something called as foreground style, right? Now, foreground style, basically a style in Swift UI can be a variety of visual elements that refer to a type of color gradient or refer to a color by its position placement in an app. So foreground it basically stands for anything in the front, right? So this has been removed right now. This is removed. So now we will see about what foreground style is, right? So foreground style is anything can be a variety of visual elements that refer to a type of color. So foreground, okay. So what are styles? I mean, so styles are basically visual elements that refer to a type of. So basically anything referring to a color is a style. So in simple words, anything referring to a color is called as a style. Now there are multiple um, colors, multiple styles can be there, right? For example, you can have colors, gradients, hierarchical, semantic. Okay, okay. So basically, when we are going to do, so like when we are going to write in foreground style, right? So inside what we need to mention. So suppose when we have this foreground style, right? So inside we need something that is going to refer to a color. Now this color can be anything. This color can be anything, right? So like so this style needs to be basically a color, right? So the style needs to be a color. Okay. Um so like anything referring to a color gradient or refer to a color by its position can be added to the styles, right? So now you can categorize styles into five different categories, right? So there are so styles can be further classified down into different things. First is basically a simple color, then is again gradient. These are direct, right? So gradient again it's related to some color thing. Then you have uh, material, then you have hierarchical. So once you have hierarchical, and then you have semantic. So it does make sense, right? So foreground is referring to front and style is referring to some sort of color. So okay, and now so we did use foreground style, right? Okay, now let's see something about like resize. We did resize, right? We did something called as frames, I guess. Yeah, we did resize it using frames, right? So let us see that frames thing. Mm, okay, so the next thing is frames, right? Okay, let's see about frames. And we also did a resize on the image, right? Mm, okay. Oh, we did see foreground color, so that is not an issue right now. Thing is to okay frames. Now when okay, so now let's see about frames, right? Now when laying out your screen, Swift UI does a great job of spacing and positioning. The default placements combined with spacer views and padding modifiers can go a long way to help you to create your ideal layout. But when you want to really take control of a sizing, the frame modifier is used to help. So basically using the frame modifier we are going to adjust. Basically we are going to work on the size right now. So fixed sizes, okay. Okay, so now lot of like things can be passed in, right? The first is fixed size. So whenever you are giving a fix, so first way to so like using frame, first thing that we would be giving is a fixed size. So when you give a fixed size, you mention a height and width, right? So you do height, and width, then this is fixed. The next thing basically we do is minimum and maximum. So we do minimum and maximum, right? Now basically for example min height or min width, right? So we can give min and max range. So infinity is basically yeah, so what does now there is something called as yeah infinity here. Let me check that. So whenever we are dealing with minimum and maximum sizes, there are two things that we generally do. So this is Now infinity is basic, it's a special value, it takes basically use as much as space. So now a dot infinity is a special, this is a special CG point value, special CG point value. What it tells is use as much as space available. So it tells to use okay, it basically indicate, it tells um use as much as space is available. Okay, so basically we are going to so if it's if we make the max width to be so width, now if you see it this way, if you see along the axis, so okay, this is not correct, so let's let's have this. This is going to be y axis, and this is my x, right? So if whenever you are measuring height, it's with respect to this y-axis, right? So height is measured along. So height is measured with respect to y. Whenever we are doing width, it's basically, so whenever we are going along width, is x-axis is going to be width. So if we say max width to be infinity, basically what we are saying is take almost the space available along the x-axis. Okay. Uh, okay, that is so. Now what if, so using this, what, so some views are going to pull in, right? So by what we can do is, we can change the behavior. So some, when we say pull in views, those views are only going to take as much as, so views can be, by default views have two behavior, either it can be a push out or either it can be a pull in, right? So pull in will only take will only occupy uh, so if it's a pull in, it's only going to occupy. So what I was saying is views can be of, if you're having views, then you can categorize into two types. One is going to be pull in and push out. So pull in views only takes only occupy content space. So only occupy, so as much as there is content available, it will be occupy only that much space on the screen. So what we can do is, now you can make this to take the entire width of the screen by using max width dot, like, if you can, you mention this to be infinity. So this is along the x, right? So this is going to stretch along this axis, and then now you mention the max height as well. So you mention the max height as well to be infinity. So now we are going along the y-axis. So this is basically how it's going to work, right? So what we have done is we have made so this is, so if I apply this on a pull in view, so my pull in view has changed to a push out view now. So what has happened is my pull in view has become a push out. Okay, sounds fair enough. Now, there is one more thing that we did, right? What we did is we were working with images as well, right? Now, okay, there is some parameter called as something called as z index, right? So there's a view called as, it's a modifier, I guess. Is it? Yeah, it's a, yeah. So there is a modifier called as z index, right? So what by default, so by default views are displayed in the order in which they are displayed, right? So views are um, so by default Swift UI is going to run this top to bottom, right? So using z index what modifier, what we can do is uh, we can we can change this default, we can change this default behavior. So what I'm trying to say is when you apply that dot z index modifier to it, so if it's uh you so the order of the views in a layout view, right? So if it's a layout view like with stack, it will put the last view on top of the others. So if you want to change that layering or ordering, we can use the select index modifier to move views. So what if this is a v stack, right? So if I have a v stack declared, so what is last is going to come on top. So if this is my, so suppose this is my container, right? And then I'm having a v stack, that is basically a vertical stacking of elements being, so this is, if suppose if this is the v stack. Now, the v stack will put last. So whatever is the last two. So the last two. Um, so last view will. So basically, the last two is going to come on top of the others. Okay. So this is how reordering is going to work. Then you have some. Then we also did. Okay, let's work with images. Let's work with the image view. So because image view will come in. Okay, let's go back and let's see. We did saw system name, right? System name is basically a bunch of. Okay. Um. Did we? Yeah. We also used a symbol, right? So do we? Okay, we have come to modifiers. So before that, wait. We need to check the views, right? So where is that? There should be an image view, right? I'm just checking that. Let's see now. Uh, okay, this is not what we want. Now even foreground style is a modifier. We haven't. It's not a view as such. Just be careful about that. Mm. Okay. So the foreground style takes in a view. Now that view has to be something. Okay, first let's start with images and then we will see. So now we are going. Okay, this is the image view, right? So image. So this is a view. Remember, now we are working with a view. So basically, image view can be used to show your own image. It can be either it can be a own image, or we can already use SF symbols or system by using the SF symbols. When we use that, we need to use the system name initializer. Okay, and now the image is a pull-in view unless you apply. Okay, now there is one thing. So this is going to be a pull-in pull-in view, and then so when we apply the resizable modifier to it, you are going to change it to push out. Okay. So yeah, image. Now, whenever we are going to do resizing, right? So whenever we want to resize an image, we use something called as a resizable modifier, right? So we add in resizable. So by adding that resizable, uh, what we are going to do is we are going to make it a pull out. So by adding a resizable modifier, it kind of becomes a pull out view. We make it pull out. Okay, now there are even when you do resizing, right? There are three ways. Either you can give it so suppose if you want to change the size, right? Either you can use frame to give it a height and width. You can do something called as scaled. You can use a scale to fit modifier as well. There is something called as scale to. There is scale to fit versus fill. We need to see that, I guess. Okay, and okay, we'll see scale to fit, and there is one more fill, right? We'll see what is the difference between fit and fill. We already saw how frame works, right? Now, what if this is an image, right? I mean, suppose if this is the size of the image, and what if we want to clip some? What if we want to make it inside? We want to this image to be a circle, right? So what we can do is we can clip this image like. So we want this thing to be a circle inside, right? So clipping can also be done. So we can clip these portions. So the way clipping is the clip, you can use the clipped modifier, and then it will take in a shape, right? Like what shape has the clipping to be. Okay. And symbols we said right now to resize the symbols. If it's a SF symbol, right? If we are giving it a system name initializer, whenever you're resizing SF symbol, we use something called as we use font. Now use image scale will allow resizing with dynamic text if set to large. Now you can scale images using image scale modifier. Yeah, so there is something called as an image scale modifier. So I have first is image scale modifier. Neither this can be a large, medium, or small, right? Now you can also change the size with the font text styles, right? So the one more way of working or changing the size is you do font and then you can change it. You can also change the size with the font, right? So you can apply a font modifier. Now text styles also allows the image to resize with dynamic type. The other way is basically font point size. Now, for example, you can do font and font sizes do not resize with dynamic type. See, okay. So he's saying if it's font, so we can do it with font as well. And then there is one more method of it. So we can do as there is something called as font point size. So this does not this lacks dynamic, right? It lacks dynamic behavior. So avoid this kind of we need to avoid this. You can have okay now if what if you want to make the font thicker, right? Just as fonts we have weight, symbols have weight too. You can change, so we can add weights as well. So weights is basically thicker, right? Like the border will be a bit thicker. So thickness of SF is when we can add the weight modifier in it, just as fonts. And so we can color as well. So now some SF symbols have more than one color that you can enable by using the rendering modifier. So if it's a you can add in colors as well. So adding colors to SF symbol. So if I want to add colors, then we use something called as the rendering modifier to it. Now uh, if used in a button, change the color with the semicolon modifier. Now what if we do Java system range? So we can change the no, the rendering mode. So for example, you can by enabling okay. If the symbols are more than one color, then you can enable that by adding a rendering mode. So what is it doing? Is no, I'm so if it's a so there are certain SF will have default colors as well. You can use that by adding a rendering mode behavior, and then when applying the tint, only the main color of the image is changed. So then you apply it like a tint or something. So when you apply this modifier, it changes the main color. The main color. So every SF symbol will have a main color, right? So the main color of that SF symbol will change. If it's not the main color, then it might not change. For example, oh yeah, then you can apply it using foreground color as style as well. So yeah, so basically to change that, to indicate that we are going to work on the color, you need to mention this rendering color mode, and then you can make mention inside. Uh, Yeah, you can have symbol. No, symbol where you can use a symbol where modifier to switch between different variations of the same symbol. For example, yeah. So every no, this is something that we need to talk about. So SF symbol have two variants. So one is like a fill, and one will be the normal one, right? Fill is basically you will have inside color. Yeah, you'll have a fill dot fill, and then you will have dot none, I guess. So symbol variant fill is basically it will be filled inside. So inside there will be like it will be inside color will be there, and none basically will only have outline. Inside there won't be any color. Then the symbol rendering mode. The symbol rendering modifier gives you more control over how sub symbols will be drawn. For example, monochrome. What does it do though? Then you can add in some effects as well. There's something called as symbol effects. For example, yeah. For example, if you want the SF symbol to continuously rotate, you can add in something called as um, symbol effects. Symbol effects is rotating the SF continuously or something like that. So to sum it up, for SF symbols, first we saw that SF symbols either you can be also yeah, this is like Saint Francisco or system name, right? So you need to have to use this. You need to use the system name initializer in my image, right? The next thing that we see is by default this is going to be pull in. So if I need to make it a push out, I need to add a resizable to it. So you add in resizable. Now we can change the original color of it by when you do a rendering mode, you can change the color. Now if I want to play with the size, then first thing is basically the frame. First is the frame modifier. Then we can add something called as image scale as well. That is also going to work with the size, right? Okay, there are three different ways for doing. So if it's no, yeah, we were resizing it, so we did yeah. So frame. Then we saw there was something called as scale to fit or fill. We'll see that what fit and fill does. And then we have something called as there was one more, I guess three was there, I remember. So why do we need to make it a pull out view is what I'm wondering. Also, if there is no we don't add resizable, it won't stretch or shrink because it's a pull in view, right? So yeah, so to change we need to have this resizable thing because by default it will only take content size, right? So even if you add even if you add in like frame or something, it won't work on this because it's by default it's content here. It's only designed to fit in the content. Now there is something called as scale to fit and fill, right? Let me check. So what's the difference between each of them? Okay, so when we are using the scale to fit version, the aspect ratio is maintained here. So here we are maintaining the aspect ratio and no cropping. Here I guess what we are doing is we are trying to fit the entire frame, and cropping will occur over here. This will try to fit, like it will try to fit entire image. This will crop out the image. Okay. The next thing that we saw was we also like SF symbols have something called as a weight, right? Either it can be a fill or it can be a none, right? So just like text, you can add in weight over here. What else did we see about SF? So resizing we saw. Clipping, yeah. So you can clip images by using clipped modifier. So this is like clipping based on a shape, some shape. So you can do the clipping. Um, the symbol sizing is basically okay. You can size. Okay, you can also. So this was with respect. Was it respect to? Or this was with respect to image? I feel frames. Or this was with respect to images. SF symbol is a special type. If you want to resize symbols, then we use image scale, font, or yeah, font. So this is for image, like not for SF. These are for images. And if I want for if we want to size symbols, if you want to do symbol sizing, then you can do either image scale, then we can do font. We can use font. Okay. The next thing that we want to see is something. Do we want to see more about text, right? Text has a lot of oh, did we see? No, let's yeah, text has a lot of things. We did use so we did padding as oh, let's see the padding modifiers. Padding is basically adding space inside, right? So you can add in space inside. It's a modifier. It's going to add in. Okay, let's see padding. So these are all modifiers. So padding is basically okay. Now padding is a modifier that can be used in many ways. Basically, we are going to add extra space around the views. You can control how much spacing is added. So, for example, if spacing around the view, remember. So basically, padding modifier. So this is a modifier. Remember. So the job of padding is basically to add spacing around the view. You can control how much spacing is added. For example, you do padding. So if by default, if you do only use this, right, it's going to add padding in all direction. So if only use this, this is like all direction padding. Now you can control that by adding only in a specific direction. For example, you want to 10. Now it wouldn't make any sense to add by default. Yes, spacing has been added. Now when you put a value, that much value is going to be padding is going to be added. Okay. So what if now if you see now this is not a text, right? So if it's not a text, now you have that top or left, right. So here you have that vertical control, right? So if you want to add, oh, why does the arrow always? So this is the vertical padding, and then this is the horizontal, right? So if it's so you can like mention in this you can mention vertical and horizontal. So here you can so here we can mention a vertical, and so if it's you can put in vertical, and then inside you can horizontal. So based on that, padding will be applied. So when you mention vertical, it's both on top and bottom. When it's horizontal, it's both left and right. I guess you can add in more control over it. There is so insets. Yeah. Now when we do so leading and so leading is basically with respect to the so you can add in leading, lagging as well. You can do then this it depends on what we are using. If it's a text, then it makes more sense. So you can do leading, trailing, top, bottom. We can add all sorts of things. Yeah, remember if you're yeah. So this kind of accepts an array if you have multiple thing present here. Okay. Let's now. Yeah. So I guess that is all for this. Yeah, we saw scale to fit and scale to fit. So scale to fill will try to fill the entire image, and it will maintain the aspect ratio without any clipping. However, if it's scale to fit is to like cropping might occur. Oh, sorry. Scale to fill will go beyond a frame. So, for example, if the size of the image is greater than the view, then if it's scale to fill, it just needs to fill it. It might grow outside as well, but if it's fit, yeah, the name fit suggests that only the size has to be taken. The aspect ratio will be maintained. Now, it may, what do you say? It may shorten the size, I guess. Something, yeah, it may reduce the size of the image, I feel. Does it, what if, okay, so for example, image has its own view, right? You can adjust. Oh, yeah, what if we change the size of the image and we make it a resizable? So, will it crop anything? So here you can, so it will grow in either height or width. Either its height or width matches the frame size. So something has to match. There won't be any cropping. So in one direction you might get an empty space, but then yeah, it has shrunk that image. Okay. So scale to fit can, it will try to fit the entire image in the frame. What if, yeah, if the frame width is smaller, then it might either match the height or the width, and it might scale down or scale up depending upon what is needed. It might scale down, and on one you can have an empty space, but when you do scale to fill, basically you are trying to fill it, and it might go outside the frame size. So yeah, that's all for this lesson. I hope you guys liked it. I'll see you guys in the next one. Please subscribe to my channel, and we'll be seeing a lot about text, right? There's a lot to think about text. So yeah, that's all for this session. Hope you guys liked it. I'll see you guys in the next one. Till that time, take care.